Let's be clear, you clicked on a video titled "What Really Killed America's Largest Bear," and you're in the right place. In just the next minutes, we'll piece together the story of Arctodus simus, a predator that could rise taller than an NBA rim, a scavenger that may have bullied saber-toothed cats, and an omnivore that could grind plants as easily as meat. Archaeologists have even uncovered its remains in Clovis-age deposits at Lubbock Lake, and alongside Paleo-Indian artifacts in Sheridan Cave, evidence that humans and this giant truly shared the same ground. But the real question isn't simply how it lived. It's why, despite its power, it disappeared around 12,800 years ago as part of the Great Pleistocene extinction pulse. Its fall wasn't the result of one single cause, but a tangle of climate shifts, competition, dwindling food, and human presence. And before we can understand how such a massive predator met its end, we first need to see what made it stand so far apart from every other bear that has ever walked the earth. Imagine an animal so large that if it reared onto its hind legs, it could stare down at you from over 10 feet in height. That was Arctodus simus, sometimes called the giant short-faced bear. It was massive even by bear standards, with males commonly estimated around 1,500 to 1,800 pounds, and some of the largest specimens reaching roughly 2,000 to 2,100 pounds, close to the weight of a small car. The smallest adult males may have been closer to 650, 900 pounds, while many females stayed under 100. Standing upright, certain individuals could have measured between 8 and 11 feet, far beyond what we see in modern bears. Size alone would have made it imposing, but its bones suggested an animal that did not fit neatly into the molds we recognize in predators today. For decades, reconstructions emphasized its short face and what were thought to be disproportionately long legs, leading to visions of a pursuit predator sprinting after Ice Age grazers. The deep, shortened snout created an illusion of shortness at the front of the skull, which only added to this dramatic appearance. Early paleo art often doubled down on this picture, portraying it as a kind of bear built like a greyhound chasing bison across the plains. Yet more recent biomechanical studies suggest the truth was more nuanced. The limb proportions were not extraordinarily elongated compared to living bears when carefully measured relative to body size. What looked like running equipment may instead have been a body optimized for covering ground in a slow, efficient way, less a high-speed hunter and more a tireless traveler. This shift in perspective reframes the central debate: was Arctodus an ambush predator that could summon short bursts of speed, or an endurance wanderer that lived by patrolling immense territories? The evidence leaves room for both. A bear of nearly a half-ton or more might manage a burst of speed, perhaps up to 25 miles an hour, but agility and maneuvering against nimble prey would have been limited. On the other hand, a long, stiff-legged gait would have let it range across open country in search of carcasses ready to claim them from smaller carnivores. Either strategy suggests power, but not in the same way. The implications also extend to diet. Bone isotopes in some regions point toward heavy meat consumption, while tooth wear patterns tell a different story, closer to the omnivorous flexibility of modern bears. That ambiguity mirrors its build, colossal, imposing, but not rigidly specialized the way saber-toothed cats or dire wolves were. It seems less like a fine-tuned predator and more like a giant opportunist, using size and stamina to exploit whatever resources were at hand. And this enormous frame was only part of its identity. The Ice Age world was crowded with competitors, predators, and scavengers that left little room for weakness. Understanding how Arctodus moved and fed is one thing. Seeing how it secured its place among other powerful carnivores is another, and it is here where the bear's story becomes more contested. On the Ice Age plains, Arctodus occupied an arena already full of rivals. North America hosted saber-toothed cats like Smilodon and Homotherium, packs of dire wolves, and eventually humans armed with newly crafted stone weapons. These pressures made every carcass a contested prize. Into this crowded mix stood a bear whose size alone made it impossible to ignore, yet the question of how it actually fit into this competitive landscape has sparked decades of debate. Three main hypotheses dominate the discussion. The earliest model, proposed by Bjorn Curtin, pictured Arctodus as a pursuit predator, using long strides to chase prey across open country. Later, Armathias argued that its real strategy was kleptoparasitism, arriving late at kills, but forcing other carnivores away through sheer mass. More recent ecomorphological studies examining limb proportions, tooth microwear, and multivariate comparisons with living bears favor a picture of an adaptable omnivore with a broad diet. Each of these models finds some support in the fossil evidence, though none captures the whole story. Geography adds crucial nuance. In Alaska and Yukon, Beringian specimens show high nitrogen isotope values consistent with heavy reliance on meat and possible scavenging of ungulates during harsh seasons. By contrast, populations further south, such as those near Rancho La Brea or the Channel Islands, reveal isotope patterns tied to C3 vegetation or even marine resources. Microwear studies echo this variability. Some teeth show the heavy scratches of bone processing, while others bear wear indicative of fibrous plants, fruits, or roots. Taken together, these lines of evidence suggest local populations adapted flexibly to whatever resources dominated their environments. That flexibility helped, but size itself may have been Arctodus's strongest tool. One plausible ecological scenario imagines a dire wolf pack exhausting itself to pull down a bison, only to be displaced when the bear arrived. Its bulk would have made resisting risky, and even when saber-toothed cats stood their ground, their specialized slicing teeth often left marrow and tougher tissues untouched resources an Arctodus could exploit. Seen this way, intimidation, opportunism, and dietary breadth all combine to sustain the species across varied habitats. Humans were also part of this contested landscape. At Lubbock Lake in Texas, a processed Arctodus skeleton dating to nearly 13,000 years ago preserves cut marks and signs of butchery evidence that it was at least occasionally killed and used by Clovis groups. In Sheridan Cave, Ohio, Arctodus remains appear alongside stone artifacts and the bones of other Ice Age fauna, hinting that people and these bears shared not only the same ground but also at times the same resources. These encounters do not prove humans hunted the bears frequently, but they demonstrate that contact was real and potentially dangerous. So Arctodus ruled a kingdom of constant tension, defined less by clear dominance than by negotiation with competition, shifting diets, and occasional clashes with humans. It looked like a top predator, carried the presence of a scavenger, and behaved with the adaptability of a generalist. For a time, those traits allowed it to hold its place among the strongest of the Pleistocene. But if it was so versatile and well-equipped to navigate these challenges, the lingering question is why a giant seemingly built to thrive ultimately disappeared. Unraveling the death of a giant means looking beyond any single explanation. Around 12,800 years ago, Arctodus simus disappears from the fossil record, its last reliable traces marked at sites like Huntington Dam in Utah and Bonner Springs in Kansas. That timing mirrors the broader late Pleistocene extinction wave when mammoths, ground sloths, and saber-toothed cats also vanished. But like those animals, Arctodus did not fall to one cause. Its extinction instead reflects a set of pressures acting together: climatic shifts, shrinking prey genetic frailty competition, and human presence all pushing at once. The most immediate backdrop was environmental change. As the Pleistocene gave way to the Holocene, the vast grasslands that once supported immense herds of herbivores fragmented. Ice retreat and warmer, wetter conditions encouraged denser woodlands, while open pine habitats disappeared. On Vancouver Island, fossil evidence shows that Arctodus survived in open pine landscapes but disappeared when spruce and hemlock forests replaced them around 12,450 years ago. On a continent-wide scale, similar vegetation turnovers meant that many of the large grazers Arctodus depended on also declined, leaving fewer carcasses and less prey to sustain such massive carnivores. Hidden within the species itself was another vulnerability. Genetic studies of mitochondrial DNA from over 20 specimens revealed just 7 haplotypes, a level of diversity so low that modern biologists would consider it a red flag. Low variation makes adapting to sudden ecological swings far more difficult and can increase vulnerability to disease. Arctodus was already navigating an unstable world. Its narrow genetic foundation meant that its room for error was slim. Competition fed into these difficulties. On Vancouver Island, short-faced bears and brown bears overlapped after deglaciation, but their relationship was more complex than a simple replacement. Isotopic evidence suggests that brown bears leaned on broader omnivory and could occupy niches left when resources narrowed. In several regions, Arctodus disappears before brown bears reappear, indicating that brown bears likely filled openings rather than forcing them out directly. Still, their broader genetic pool and dietary flexibility gave Ursus arctos an advantage in shifting environments where specialization and massive food needs became liabilities. Humans added one more layer of pressure. Direct hunting evidence is scarce. There is no sign of systematic targeting the way we see with mammoths or bison. But at places like Lubbock Lake in Texas and Sheridan Cave in Ohio, cut marks and associations with tools reveal that people occasionally butchered bears. More significant may have been indirect humans competed for the same prey and scavenged carcasses, narrowing opportunities for a large carnivore already operating at the edge of its limits. Taken together, Arctodus fell during a period when habitats transitioned rapidly, prey collapsed. Adaptability mattered more than strength, and humans inserted themselves into ecosystems already under strain. Its extinction illustrates how several smaller pressures can act together with devastating results. And while no rival alone toppled it, this giant could not navigate a world that demanded faster change than it could withstand. Arctodus left behind a record of power mixed with vulnerability. It combined massive size, a wide range, and even some dietary flexibility. Yet the intersection of rapid climate change, collapsing prey numbers, low genetic diversity, and competition with other predators eventually ended its run. Strength alone could not guarantee survival when the world shifted this quickly. That balance between adaptability and specialization remains the real lesson from its story. Given the evidence, climate genetics, and competition, what do you think was the decisive factor? Share your thoughts in the comments, and don't forget to subscribe for more Ice Age stories.